Hello everyone, welcome to AP Calculus. So this question says let g be a function such that at the -1 it is 0, at the 2 it is 5. Which of the following condition guarantees that there is an x between -1 and 2 for which the output of the function is 3? So let us take this graph. At the -1 it is 0. So this is the point -1 comma 0, and at the 2 this is 5. Let's say the 2 comma 5 is over here. There is 3 somewhere in between 0 and 5 output. Now we want to see which condition guarantees that there will be a input for which the output is 3. First point says g is defined for all x in the interval -1 to 2. If g is defined for all x in the interval -1 to 2, this does not guarantee actually, because it might be possible that for all the values it is defined, let's say up to here it is taking the value and directly it is taking a jump from here to here. Let's say this is the 1. So till 1 it was the value less than 3, and just after the 1 it is taking a sharp jump over here and it is not touching the 3. So this does not guarantee that it might be possible, but does not guarantee that it will take the 3. So this option is false. Same goes with the option C also. You can see g is increasing. Increasing function does not guarantee that it is a continuous function. Like the same case we can say this is an increasing function, but still it is taking a sharp jump over here. It does not guarantee, increasing does not guarantee continuous function. So again, this increasing does not guarantee over here. Second thing, if you look at the option B says g is continuous for all x in the closed interval -1 to 2. Now there is a theorem which is called Intermediate Value Theorem. What does the theorem says? That if a function is continuous in the closed interval, then between any two output values, like the two output values are 0 and 5, and 3 lies between 0 and 5. So if 3 lies between the two output values, then there will at least one value of x exist at which the f of x will be equal to 3. For this 3, there will at least one input value in the interval -1 to 2. This is guaranteed by the intermediate value theorem. Only condition is that the function should be continuous in the closed interval. So from here we can say that this thing guarantees. So if g is continuous, this condition guarantees, because if you make a continuous function from here to here, you can see that there will be 3. At the 3 there will exist one input value. It can be more than one input value also, but at least one input value will lie. So this second condition guarantees. According to the option D, it says there exists an x in the interval -1 to 2 such that g dash x is equal to 5. Now from this one we are not getting the information about the value of the function. Is there any value of x at which it is 3, because it is saying there is some point between -1 and 2. This is -1, this is 2, at which the slope of the tangent is 5. Slope of the tangent is 5, it can be like this, right? Let's say at this particular point the slope of tangent is 5, but this does not guarantee that it will take the value 3 at some input value. So this is also false. And the last option says -1 to 2 gx dx is equal to 3. This indicates that the area under the curve from -1 to 2 is 3. Now area under the curve from -1 to 2 does not guarantee also. This is -1, this is 2. Let's say this is 5 over here and this is 0. So the function like area under the curve could be anything. It could be a decreasing function also, or it could be a discontinuous function also. Discontinuous, just like we have drawn earlier. It could be like this and it could be like this. So area under the curve indicate that this area and this area. So this area under the curve does not guarantee that it will take the value as 3 for some input value of x. So the only condition which will work over here is that the g has to be continuous, and the reason is intermediate value theorem, we can say. I hope you have understood this thing. So thank you for watching this. If you have any doubt in the AP Calculus, connect with me on this WhatsApp number. Thank you.